right, so there we go. So, all right, so 6.8, there's question number 2. So this section, complex rational expression is a fancy word for fraction. Rational, ratio, one thing over the other. So rational expression means fraction. Complex, rational expression, complex fraction. What that means is fractions over fractions. Was that a 3/8? Yeah, 3/8. See how there's fractions over fractions? All right, is that what you were hoping for when you woke up this morning? You're thinking, I love fractions a lot, but what if we could put like fractions over fractions? That would be totally cool. Well, here you go. Yeah. That's right. I know how you think. Okay. So what do we do about them? We just focus on the common denominator. 8 is the only denominator, and you just multiply everybody top and bottom by that 8. Right? Everybody gets now. Notice there's no equal sign. So I'm not thinking left, right, I'm thinking top, bottom, because there's no equal sign, right? So everybody gets an 8, basically, so including the ones. Everybody gets an 8. So this is what we always do with a complex fraction, is we multiply everybody by the common denominator. In this case, the only denominator, 8.
Okay, now, 8 being equivalent to 8, it would be 8 over 1, not 8 over 8.
Correct. Well said. Yeah, 8 means, yeah, you're right. If that helps you, let me write it that way. 8 over 1, sometimes that helps people. So if it helps you, great. If not, don't bother with it. But you're right on. It's 8 over 1. That's exactly what 8, any whole number alone means over 1, doesn't it? So if that helps you, feel free to do that. Okay, now, remember what happens whenever we multiply like a fraction by a whole number? These guys cancel, huh? The cross canceling. And same thing with these guys. That's why we're doing it, huh? Because I joked around, but truly we don't like complex fractions. We want to clean the thing up, don't we? We want to get rid of the mess. So that's why we're doing it, to get rid of those extra messy pieces. So what does that leave us then? 8 times 1 is 8. Minus 5. Because all that's left here is a 5, huh? Because the 8's canceled. And then 8 times 1 is 8, and all that's left here, that's plus 3. And then that's just what? 3 over 11, and we're done. Does that make sense what happened there? Or the Casio Natural Display, just hit the buttons. You can type that whole thing into the Casio Natural Display. Now, in a minute, we're going to go to letters. So then the Casio Natural Display is out of luck. Right, it can't handle the letters. So we still need to learn the game plan. Well, it can't handle you can type them in, but it won't actually solve them. It can't actually do it, yeah. Anyways, that makes sense what we do. So you multiply top and bottom by the 8, the common denominator. All right. So what does that mean? That means this whole big ugly mess is the same thing as just 3 11ths. We just cleaned it up. That's what we're basically doing. We took it from a big ugly complex fraction to a much simpler normal fraction. All right. Yeah, it's a big day. And then Monday's our test on all that stuff. All right. So here we go. So we have 5/3 plus 2/6 over 6/11 minus 8/22. Okay. Yeah, this is an ugly one. I'm trying to think what the easiest way to do it would be. Okay, I guess what the easiest thing to do would be to take all those denominators and put them in a big L box. So I mean the 3, the 6, the 11, and the 22. So I'm grabbing all the denominators, and I'm trying to find what's the common for all of them.
Now, when you have 4 different numbers, only 2 of them have to have the same in order to factor.
Right, 2 at a time for dividing out. You're totally right.
Okay.
That's exactly it. Yeah, so right away we can say like, well, let's do the 11 right away, right? 11 goes into 11 and 22. Or we can start with the 3. 3 goes into 3 and 6. Right? Yeah, either way, I'll start with the 3 maybe. 3 goes into 3 one time, 3 goes into 6 2 times. 3 doesn't go into 11, 3 doesn't go into 22, so I just bring them down, right? So So you divide out of 2 at a time. And then, now I can do an 11, right? You could start with the 11, then do the 3, doesn't matter. 11 goes into 11 once, 11 goes into 22, not 22 times, twice. And then just bring down the 1, bring down the 2. And, oh, we could do 2 now, huh? We can do 1 more. I didn't notice that. So 2 goes into 2, 2 goes into 2. Now the 1s, they just come down. Yeah. Good? Now what's our common denominator then? How do we find it? Yeah, it's multiply, 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 and then the 1s aren't going to do anything. Just times, 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 times. So is that 60? Yeah, 66. So that means the LCD, the common denominator, is 66.
So for the whole group.
Yeah, for the whole group, for all 4 of them,
Right.
for all those denominators. 66 will swallow them all. It'll take them all.
Break it up into 2 groups.
You could, it's harder that way because then you're doing different things, but that's technically allowable. It will work. Yeah. All right, so this is easier. 66. Now, what are we going to do with that 66? Is this a left-right? Is there an equal sign, or is it a top-bottom? It's top-bottom. There's no equal sign. So everybody gets a 66, right? And if you want to put it over 1, you can, if that helps you. You don't have to. 66 alone means over 1, either way. But everybody gets 1 wrong. And then you just use your calculator and divide, or you're going to cross-cancel each of those denominators. Be careful. Cross-cancel each of those denominators and multiply what's left over. So like, I'll do them one at a time. So 66 divided by 3 leaves what, 22? And the 22 and the 5 is 110. Yeah, the leftovers multiply, right? Good on that first one. Try the other 3. Cross cancel, multiply what's left over, like we did in the other section. Six goes into, I'm erasing it there. 6 goes into 66 11 times. Multiply the leftovers. 2 times 11, 22. So far, so good. And then 11 goes into 66 6 times. Multiply the leftovers. 6 times 6, 36. Oh, minus down there. Good. And then 22 goes into 66 3 times. Multiply the leftovers. 3 times 8, 24. We're getting to there, okay? And so what is that? That's 132 over 12. And is that reduce to 11?
Yeah.
Oh, nice. That means that
Casio natural display.
goes straight to 11? Yeah. Yeah, how nice. Yeah, that means that big old ugly mess is a fancy way to say 11. That's what that means. It's just a big fancy way to say 11. That's the answer. Yeah. Yeah. That's, I'm a math teacher, obviously, and so when I raised my kids, I taught them to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then say this instead of 11.
Oh.
No, I'm joking. I'm joking. That's
Not, but on the homework that we did, it said the proper or improper correction.
right. Meaning the top bigger than the bottom.
Yeah.
It doesn't say that.
Oh no, I mean then it did the.
They wanted mixed numbers?
Yeah.
Or answers or wanted mixed fractions.
Yeah, on the work ones, the working together problems. I remember that. It did want mixed in that.
Why is it wrong and it makes you know how to give it
Yeah, that's right.
And I don't remember how to do those stuff early, so I didn't finish the homework. I was those problems because they were in mixed fractions.
Okay, let me help real quick. Yeah, because that was section, what was that? 6.7? Yeah, 6.7, you're right. The workbooks are mixed. So if you have something like 10 over 3, well, let's make it more interesting than that. Say you have something like 14 over 3, you divide. How you change it is you divide bottom into the top, like that. The 3 goes into 15, 14, what, 4 times? 12, and then the bottom over the left, 2/3. Bottom over left. That's how you convert from a improper to a mixed. You divide. Divide the bottom into the top. And remainder over the left side. Yep. Bottom over left. That's it. And remember how you can check to see if it's right? Remember you multiply 4 times 3 is 12. Add the top, 14/3. See how it goes back? See how the denominator never changes? If it was thirds before, it'll end up being thirds. Denominator never changes. Yeah. So that's right. I forgot about that section doing that. On the test, Monday, don't worry about that because say the answer, say you get 14/3. Let me show you something. This will be good precursor for the test. Say you're looking at the test on Monday and you get the answer 14/3, and you look down here and they're like 7.5 and 3 2/3 and 4 2/3 and 4 7/9, and you're like, well, I don't know which one. I got 14/3. Just make them all decimals. Just divide this on your calculator, decimal. It'll tell you 4.66666. This one, decimal it on your calculator, 7.5. Decimal on your calculator, 3.666. Decimal on your calculator, 4. And you go, oh yeah, that's it. Same decimal. Does that make sense? Just turn them into all decimals. You can just make everything decimals since it's multiple choice on the test Monday. So you don't have to worry about certain forms. Any form is fine, right? You know how you do it, right? Just go 2 divided by 3. And that, and that makes the 0.66, and you know the 4. Oh, you got the great Casio. It'll change forms by the SD button, right? It'll just hit that SD button, changes all the forms. Yeah, it's very nice, very nice. All right, so 1 over x plus 3 over 1 over x minus 6. All right, same thing, now come the letters. No more Casio natural display, able to do the whole thing all at once. This marks the end of the power of the Casio natural display. So, got the letters. How are we going to, same thing, it's a complex fractions, fractions over fractions. We want to make it cleaner, simpler. What do? Same thing we've been doing. We look at all denominators. That'd be this guy and this guy. Those are the only denominators, the only things under bars.
Because theoretically speaking, 3 and 6 is over 1.
Right. Totally right.
1 times x is x.
So what's the common denominator then? Just x. It's the only denominator. It's just x. Exactly right. So what do I do with the common denominator?
You times
Everybody gets one. Top and bottom, because we don't have an equal sign. It's not left, right. Now, and if it helps you, you can put that over 1 if that makes it easier. It always means that, right? Anything alone is always over 1 if that helps. And do the same thing. Cross cancel. Multiply what's left over. Getting that okay? So the x's cross cancel. What's left over? 1 plus 3x. X's cross cancel. 1 minus 6x. And we're done.
Wait, that's the
Yeah, let's talk about it. Why can't I cancel those x's like that? Costco says no. Right? Remember the glue thing, right? Remember like the that 1 plus 3x is just all glued together. It says if you want to do anything, Ken, you got to buy the whole thing or nothing, right? When they're glued together like that. So we can't buy the whole thing. We cannot afford the whole thing. So we're buying nothing. So that's just it right there. Makes sense? What did we do? We took it from a big, ugly fractions over fractions to just like a normal fraction. We made it a little simpler. That's what we're doing. Complex fractions to regular fractions. Simplifying.
Are you doing math when I do this? Or you...
I don't remember. I don't think summer. I don't remember. All right, so 16 minus 1 over r squared. 4, is that minus? Yeah, minus 1 over r. Okay. So what's the common denominator this time? So we're looking at the, there's r squared and r, those are the two denominators, right? Now remember what the rule is for finding a common denominator. One of every variety. If you shop at a Target, I'm going to buy one of everything today, but you're going to buy the most expensive version of everything. You're a big spender. So which one do we take? R squared, right? It's always the highest one of each type. So r squared, yeah. We don't put them together and make r cubed, do we? We're not putting it together. It's just one of every type, the highest, most expensive one. So r squared, yeah. And so multiply everybody by r squared. So r squared, r squared, r squared, r squared. And if it helps you, you could put it over 1. That's what it means. Cross cancel and multiply whatever's left over. So 16r squared. These guys cancel. Minus 1. That good so far? 4r squared minus. Yeah. Did everybody see that's going to be r there? Because this r will cancel. I'll just cancel out the power, leaving 1r left over, huh? Right? Because 2 on the top cancels one of the ones on the bottom. It leaves 1 extra on the top, right?
So you're starting to canceling out one of the r squared?
That's really what I'm doing, yeah. Yeah, well said. If it helps you, you could write 2 r's, because that's what r squared really is, r, 2 r's. And 1 cancels with 1, but there's the other one left over. If that helps you, you can write it that way. That makes sense? I just cancel out the power, but either way, just as long as you know there's just 1 left over there. Now, normally we stop here, but this one has got an extra trick. Just pretend they gave us this problem like to start with. What would you do to, can I cancel? Can I cancel these things? No, it's the blue, so it's all or nothing. But remember what could we factor this top? Is that factorable?
Yeah.
Yeah, factor that top. Well, you got the 16.
4r.
Oh, yeah.
Yeah, yeah, right. Remember it's an FL, right? 2 parentheses. Front times front to be 16r squared. 4r, right? Yeah, 4r plus 1 and 4r minus 1, either order. As long as you have 1 plus 1 minus, because positive times negative to make negative 1 go back. Now the bottom is a different story, though. What's the first thing we're supposed to
Take out 4r.
take out? What's in common? Whatever's in common, right? That's always first. What do they both have in common on the bottom? R, right? They have an R, so you just do the 1 parenthesis. And then just ask yourself, what would distribute to go back?
4r minus 1.
Yeah, see what'll work. R times what will go back, and R times what will go back. R times 4r, and R times 1, huh? Good. Now we can shop at Costco, because we're buying the whole package. That's fine to do. We bought the whole glued package of 4r minus 1. So what's left over then? We're finally done with this one. 4r plus 1. Oh, we don't even need those parentheses on the top anymore. There's nothing to separate it from anymore. Can I cancel those r's? Can I go like this? No, that top is a glued package, all or nothing. I can't buy it all, so I buy nothing. So we're just done right there, right? 4r plus 1 over r. That's the answer. That makes sense? That was a hard one. No questions? We good on that one? A lot of steps. Yeah, all these are potential. There'll be 1 or 2. There'll be 2, probably 2 complex fractions on Monday's test.
n over 7 minus 7 over n over 1 over 7 plus 1 over n.
Okay. So take aim at all the denominators, right?
Look at these 4 denominators.
You're buying one of everything.
So 7n.
7n is your common denominator, isn't it?
All right, so multiply everybody by 7n. 7n, 7n, 7n. Put it over 1 if that helps. And cross cancel.
So go slow, be careful. Cross cancel and multiply whatever's left over.
So 7 cancels 7. What's left over? N times n squared. Yeah. Is that good? Right. Good for that second one. The n cancels in. What's left over? 7 times 7. 49. What's happening down here? 7 cancels 7. What's left? N. N cancels in 7.
No, you can factor the top, but you can't factor the bottom.
Right. Everybody good to this point? That top is factorable, isn't it? Right? That's another FL, right? The 2 parentheses. Front times front, last times last. That good? Can you do that? So it's an FL, front times front, n times n. 7 times 7. What signs do we need to make negative 49?
Positive and negative.
1 positive, 1 negative.
You cancel.
And then the n plus 7s cancel. And we're left with n minus 7. Just like that. Right? It's in the numerator, so you can just leave it like a whole number, doesn't even need to be a fraction anymore because it was numerator, right? Good with that? Questions on that? No questions? We all good? Okay, so number 9, 1 over 6 minus 1 over b is 6 minus b over 6. I'm going to make those b's x's because my b's look like 6's a little bit. I think it might get confusing. I'm going to make those x's. All right. Yeah, 1 over 6 minus 1 over x all over 6 minus x over 6. All right, so take aim at the denominators. So look at the denominators and figure out what's the common denominator. Yeah, that's correct. It's just 6x, right? As we look here, look there. Looking at, you're shopping, you're at Target, you're gonna buy one of everything. So just take a single 6 and a single x. So 6x. How many fractions are on the bottom? That's just one fraction, huh? So he's just going to get one 6x on the bottom. See how there's 2 fractions on the top, but only 1 fraction on the bottom? So the bottom only gets one 6x.
right? So 6x over 1, 6x over 1, and 1, 6x over 1 for the bottom. Six cancels 6. What's left? X minus. X cancels X. 6. Everybody see what happened on the top there? Slow down a little bit. So everybody see how I'm cross-canceling, and X times 1 makes X. Cross-cancel, 1 times 6 makes 6. So we cross-cancel and multiply what's left over. On the bottom, 6 cancels 6. So I'm just going to, let me just write it like that for a minute first off. I mean, you could distribute it. It's fine either way.
What it's saying is negative x to the second constant. But like, in reality. Isn't that the kind of thing that you would times by -1?
Yeah. That's what we're going to do. Yeah. Yeah. Very good to hear so far, though. Is that okay so far? Right? I canceled the 6's, and I just brought down the x and the 6 minus x. Yeah, notice these are the same thing, but flipped order. Remember what we do with that? Remember what we do when we have x subtracted at the back? Called the turnaround rule, right? It's definitely going to be on Monday's test. You want to be comfortable with it. When x is subtracted, if these were added, I wouldn't even care. If they were added, I would totally just cancel them out. Just boom, boom, 1 over x, done, right? Because the order of adding never matters at all. But they're not added. They're subtracted, and that matters. Wait, what did I just do? I did something crazy. Let me try again. I lost it now. It's x minus 6 over x. Okay, yeah, here it is. Now, since there's, remember, you take this one and you turn it around, and you put a minus out front. Maybe I should do that on the next step. Let me do it in 2 steps. Remember how that works? So x, 6 minus 6. Yeah, you turn around the bottom. You turn around whenever you have x subtracted at the back and put minus in the front. You just stick it on the x that's already in the front there. Does that make sense what happened? That's called the turnaround rule. Whenever we have x subtracted in the back, we turn it around and a minus comes out to the front. Now these can cancel, so what's left? 1, no, there's nothing on the top, that always means 1 over negative x. And we're done. So everybody see that? You remember the turnaround rule thing when x is subtracted at the back? Turn it around and put a minus in the front. These cancel. Oh, that's off the screen, isn't it? So this is 1 over minus x like that.
So with this particular equation, you're only using that rule on the bottom. Okay, never mind, I see. Because in one set of them, we had to multiply the top and the bottom by a -1. So we can take the right answer.
I never did it that way. Maybe Math Excel showed it that way.
Yeah.
There's another way to do it that way. I just found it easier for students over the years. Just to turn the one where x is at the back, just turn just that one around and put a minus in the front. That'll work every time like that. And everybody okay with the 1 on the top because the top cancel? Right? Whenever the top of a fraction cancels, that leaves a 1, huh? A good question? James? Comment?
So the negative you put in front of the x,
Uh-huh.
it'll never move to the top like before it moved
It
to
could.
the top.
Either way is the same. Yeah, good question. Remember when you have a negative on the fraction, it's the same as putting it in the top or even just putting it in the front. Those 3 are all the same. I'll say or this, or that one. Those are all the same. Yeah, remember a negative on a fraction, it doesn't matter if it's top, bottom, or front. It's all the same thing. Yeah, so I know what you mean. Usually we let it float up to the top because I'm in the middle of trying to get common denominator. That's usually, and so I don't want that thing down there. I'm trying to get it covered. For now, I'm just done with the problem, so I don't care if we leave it in the bottom or move it to the top. But it's all fine. Multiple choice test on Monday. Make sure, like, if you've got it on the bottom and the answer has it in the top, you know that's the same. Grab that answer, right? Everybody, that's why that rule becomes important for multiple choice tests, because they might have moved it somewhere, and you need to know. Oh yeah, that's the same. That's my answer. Grab it. Is that good? So minus on a fraction, top, bottom, front. It's all the same. Okay, I'm going to make it an x, that t, because my t's look bad. So 1 over a squared minus 1 over... I'll make the t's into x's. Okay, so here we go. All right, try that one. Complex fractions, fractions over fractions. Look at all those. Go shopping. You're shopping at Target. You're going to buy one of everything, but you're going to buy the most expensive one. Because you're a big spender. Like me, I'm a big spender. My kids accuse me of being cheap. Constantly.
You always change it at the end of the day.
But then of course, you could have the one and then
A squared, A squared.
Sometimes that's true. That's often true. All right, so what is the common denominator? Yeah, it's a squared, x squared, right? Because you look at the four denominators, a's and x's, the highest a, the highest x. A squared, x squared. Everybody good with that? Right? When you're shopping the four denominators, you're buying one of each. You're buying the a squared and you're buying the x squared. Right? We don't take the regular a because there's a more expensive one. We don't take the regular x, we take the more expensive one. One of each type, highest. Now what do we do with it? Everybody gets it. A squared x squared over 1. 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 Like that. Everybody gets one. Cross cancel. Be careful, there's a lot of letters and powers. Cross cancel and multiply what's left over. So the a squared means 2 a's and the x squared means 2 x's. So if you cancel, there might be one left over, right? Might need to. I'm not even sure. Is that where it goes?
I think so. The bottom, not the top.
Yeah, I wouldn't be surprised. So we doing okay? So a cancels 1. Can I just cancel out the power that way? Because there's one a left and an x squared. So ax squared for the first one. Everybody getting that? See how one of the a's was canceled, but the other one's left? Plus. And then x cancels, I'll just cancel the power, showing one of the x's is left, along with the a squared, like that, a squared x. Good so far. Then on the bottom, a squared cancels a squared, what's left? X squared, minus. And x squared canceled x squared, what's left? A squared. Good to there so far. Now we do. You're right. I see. You're right. We have to factor now, huh? So now it's like two factoring problems. See if you can factor the top. Ask yourself what's in common. Like what do these guys both have? Remember when you're factoring, you take the lower power. It's kind of confusing, huh? Common denominator, we do highest power. Now factoring, we do lowest power. You got to kind of keep switching gears. You know what I mean? So now I'm factoring on the top. I look and I say, what do these guys both have in common? A and X. They both have a. They both have x. They don't both have a squared. One of them has a squared, but they don't both have a squared. They don't both have x squared. One of them has x squared, but they don't both have x squared, right? So just take out what's in common. Yeah, and ask yourself, yeah, what ax times what would go back? Be x, huh? Because that would go back to x squared. And ax times what would go back? A plus a. Good. Now the bottom, how do you factor the bottom?
X plus A, X minus A.
Yeah, that's the x plus a, x minus a thing, right? That one positive, one negative makes negative a squared. And now we can buy the package. All right, so when all of that is over, it's a long one. What's left? Ax on the top,
Over X minus A.
x minus a on the bottom. And that's it. I can't cancel anything there because the bottom is a package. Right? So that's it. Is that good?
So many steps to these when I go to do
Yeah.
my homework. I'm just like, I really don't want to do this because I'm really lazy when I'm at home.
Right. It's comfortable at home. Who wants to do this painful stuff? Yeah. Is that good? Does that make sense? I'm glad you're doing it. That's exactly what it takes. Just practice these. You'll get better and better. No questions? We good? Okay. So 3 over a minus 4 over a squared, 7 over a cubed, plus 2 over a. All right. Shop the common denominator. What's the, when we shop the common denominator, we look at the 4 denominators. What's the common? A to the third, huh? We take the most expensive one. Yeah. Good. A to the third. Put it over 1 each time. So a to the third over 1. 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 All the way through. Good. And then we cross cancel, multiply what's left over. Yeah, a goes into a cubed, leaving a to the second, doesn't it? Does that make sense? Because a to the third means 3 a's. And one of the a's on the bottom cancels out one of those 3 a's, leaving 2 a's. So it becomes 3a to the second minus, and then a to the second cancels a to the third, leaving a to the first, or just regular a, huh? So that's 4a. Good so far. On the bottom, the a cubes drop off. Yeah, and a goes into a to the third, leaving a to the second. So it's 2a to the second. Really, we're done here?
No.
I think we are. I know you're thinking about factoring the top. I'll explain why that doesn't go anywhere. It's a dead-end street. But questions so far to this point? Yeah.
They move like A to square to the left and the right.
Oh, like switch the order? Yeah, the order doesn't matter. Either way's fine. Yeah.
Yeah, but
We don't have to though, that's just if we're gonna factor or something, we're not gonna really.
Yeah, the bottom can't factor.
The bottom can't factor,
Addition.
that's why it's no use to factor the top. I mean, you could take out an A on the top, but there's no point in it, because it still won't cancel. We only care if it makes something like cancel, but nothing cancels. So don't even bother to factor the top, it's a dead end straight.
Whenever you
How would you
find
know
them
that?
up nine.
Yeah, if you're not sure, just go ahead and try it. If you're not sure, just go ahead and take out the A, like that, and then you get to here and you go, okay, did those cancel?
The bottom has a.
No, so then this is the answer right here. Does that make sense? So what I'm saying is if it doesn't make anything cancel, then leave it like it was before you were factoring. The purpose of factoring is to make something cancel, so if it doesn't make something cancel, just leave it as it was before you factored. Question?
Well, no, the bottom has a prime number and it's also addition, and you
Yeah.
can't factor it like that.
Yeah, so if you're totally right. And if you're seeing all that ahead of time, great, and you won't even waste your time. You're totally right. Yep. Good. Other questions on that one? Is that good?
Because I'll notice on the YouTube tutorials, as I'm browsing through it, like the ones I really need help on, you don't do.
That's what I try to do, is skip the really hard ones. I'm kidding.
You're hilarious.
All right. Let's try this one. This is probably the hardest one. Speaking of that, this is probably the worst one in the section, right here. So I was gonna skip it, but since you called me out, I'll go ahead and do the worst one.
No, it's like I'm doing my homework and everything is fine, and then they throw a change up, and then I'm like,
Oh, I better get to that one.
yeah, and I'm like,
Yes, Sharon,
oh my
skip that
God,
one.
you didn't do it.
There goes Roberto, our tutor. Just want to point everybody, he's there to help. Is he helpful? Good. Good. Good test. Yes. Excellent. Yeah, he has the practice exam. He'll go over that with you
Very helpful.
for Monday.
Very helpful.
For Monday. Right, so he'll be there tomorrow, no, Friday, 11 to 2. He'll be in the tutoring center, which is the library building, across from the fountain. Friday, yeah, there's hours over there on the sideboard. Friday, 11 to 2.
Yeah, I'm in grass.
All right, so
So which one? 7H? Oh.
we got to do the big box here. Well, the letters are easy. What you tell me about the A. What's the common denominator going to be for the A part? A to the fourth. Just take the highest one, right? Most expensive one. You're shopping, take the most. But the numbers are the pain. We're going to have to do a big old box and try to find the LCD for all those numbers. That's the part that makes this one extra work. So go ahead and do the. I'm going to change the color, but go ahead and do the.
They're all odd numbers.
They're not nice numbers.
3, 7, 9.
Yeah, so you can put 7 out there, goes in once, goes in twice. Bring down the 3, bring down the 9. Okay, and then what goes into, what else could go in?
3.
Yeah, 3. Once and 3 times. Bring down the 1, bring down the 2.
7, 3, 3, 2.
And that's really, we can't go any further, huh? We could do 1, but everything goes to 1, so. Yeah, so multiply these together. Times. 126, is that what it is? 63, 126, yeah, that's it, 126.
Because he said it's only straight.
Never doubt the man. He's got it, 126.
Educated guess.
126, right?
You
Now you got
gotta
to
go through
every one of them. Everybody see how I got that LCD? I just multiplied down and across, like a big L. Down and across. A to the fourth, good job. Exactly. It's 126 A to the fourth, isn't it? So 126 A to the fourth over 1. 126 A to the fourth over 1. We just got to keep doing that. This is a pain.
Why don't you have the 5 up there in the LCD?
So, oh, it wasn't a denominator. Yeah, good question. The 5 is in the top. I'm only grabbing stuff in the bottom.
Oh.
Yeah, good question. Only denominators. We're finding the common denominator. So multiply 126a to the fourth over 1 to all 4 of them. And then use your calculator. Those are some big numbers. So 126 divided by 7. Is it 18 or
18 times 5 is 9.
18? Yeah, and the a-fourths cancel, huh?
90.
And you multiply 18 times 5, 18 times 5, 90, huh? Is that good on the first one? Everybody see what happened on that first one? So you cross cancel everything you can, whatever's left over, multiplies 18 times 5, 90. Calculator. Minus. And then do the next one. Keep cranking. 14 to 126. Is that 9?
Yeah,
9. And then what about the A's? It's 9 and then, yeah, this makes a to the third, doesn't it? Everybody good with the top?
Whoa.
3 into 126. Is that 42 times? 2 times 42, 84. A squared. Everybody see the a squared there?
What is it? 2 or 3?
So 9 into 126. 14 times 5 times 14. 70.
70.
A to the third.
8
Everybody good with that? Let me see what's a to the third. I'm hoping we can stop there.
Hoping we can. I'm afraid we can.
You could factor a 9 out of the top, but who cares? You can't factor anything out of, well, I mean, what, 7 or, no, it's not going to go anywhere. There's nothing that's going to cancel. I mean, we could factor 9 out of the top, but in the bottom, what, I don't even know what goes into 84. Does 7 go into 84? 70. 7 times 12. So we can factor 7 out of the bottom, but that won't cancel with the 9 on the top. So no, we're done. There's nothing. You can fiddle around with it and factor, but nothing more is going to cancel. You know what I mean, guys? Is that okay? Like, in other words, if I'm confused, here's what you could do, but it'll go nowhere. You could take a 9 out of the top, like that. You could take a 7 out of the bottom. Whoops. 7a squared, in fact. 7a squared out of the bottom, but it's going to go nowhere. Oh, 14. We could actually take 14 out. I still don't think it's going to go anywhere. 14a squared out of the bottom. That'd be 7a, right? Is that right? 7. No, what is that? 6? I'm tired of this problem. 6 plus 5a. Yeah, that did nothing. Yeah, so don't do that. That nothing cancels. See how I factored top and bottom? And it wasn't at all easy, and nothing cancels anyway. So just boom, there's our answer.
That would really take a lot of time.
That would, yeah. And on the test and on the homework, just get your answer and look for the option. It's 95% of the time it's just that.
If you can recognize the difference of squares, go
Yeah.
ahead and factor them.
Exactly. Well said. Well said. Yeah, let's look back. I think you're saying it exactly right. Let's look back for a second. I know, because it seems like so much work, and you're like, how do I know when I'm done? I like what you're saying. Yeah, once you get down to the one fraction, if you see obviously they both have something in common, and this is a difference of squares, yeah, then go ahead and do it. If it's not real obvious, don't waste your time. It's like this. This is so ugly.
Leave it a mess.
Yeah, if it's so ugly like that, just look for your right answer. That's it. That's it right there. Okay. To the next chapter, next section, I mean. Okay, so let's try 7 over x plus 1 plus 1 over x, 2 over x plus 1 plus 5 over x. Okay. Now remember, an x plus 1 is a glued package, right? Costco glued together package. So that's an x plus 1 package. And notice what I'm saying when I say that is I'm saying we don't think about x and 1 separately. We think connected, glued, x plus 1 package.
So when we go
Solo x
everything,
package and solos. Yeah, so we go shopping at Target. Looking at those 4 denominators, you're going to buy one of every denominator.
so the common denominator is x times x plus 1.
Exactly. We need a solo x and an x plus 1 package. Yeah, that's exactly it.
Wait. Here we go.
Wait, I hope let me be clear. I hope I'm being clear. Let me do a what if. What if, whatever, blah, blah, blah. What if they had 3x and x? Because that's where it gets confusing. So I think this is worth a minute of our time. What if they had like 3x and x in the denominator? I would not think of that 3x as a glued package. It's not a package. It's just a separate 3, separate x, separate x. So when I shopped the LCD, I would say, I need a separate 3, I need a separate x. Okay, I already got the separate x. It would just be 3x that I would multiply everybody by, right? I wouldn't take the 3x and another x. Why not? Because when I take the 3x, I've already got the separate x, because that x is separate. He's not glued.
There's 3 separate.
Whereas this one's glued.
Yeah.
So I don't, when I take the x plus 1 package, I don't think, oh, I've already got a separate x, don't need that one. No, this isn't separate. This is glued.
Yeah, 3x.
Everybody see that difference?
Mm-hmm.
So pluses and minuses glue things together, making it different than a separate item, right? So when you look at x plus 1, you think that's a glued package, and that's different than a separate x. But when you look at something, say like 3x or 5x or whatever, where there's no glue there's no glue. That's a separate 3 and a separate x. So when you get to the other separate x, you say, I already got one. Already got a separate x. Don't need to take that also. I would not take 3x and x. That would be repeating, and we're not repeating. We're by one of each. That would be repeating the separate x. You've already got the separate x. Whereas over here, I do take them both, because x plus 1 is a glued package. It's not a separate x. Everybody see that? Question? Comment? So in our case, that's exactly what we're going to do. So in our case, we're going to use x and x plus 1 for all 4. We need them both. That's right. Whereas in this case, you would just use 3x. 3x, 3x, 3x over 1 everywhere. See the difference? So when 2 things are glued, they're a package. As we keep beating that drum, they're a package deal. And you can't think of them as separate. They are not separate. So it's x times x plus 1 for everything. Over 1 for everybody. So then cross cancel and multiply what's left over.
7x.
So x plus 1 cancels x plus 1, 7x. Plus x cancels x, x plus 1. Good so far. X plus 1 cancels x plus 1. X times 2, 2x. Plus x cancels x. 5. I should just multiply it right now. 5 is going to go like that, right? 5x plus 5, everybody see that? Distribute right there. Right, we cross cancel and multiply what's left over, don't we? So multiply what's left over. Seven x and x is 8x on the top. Good so far. On the bottom, 2x and 5x, 7x. And there we go. All right, I think you've got these down now. We've done almost all of them. I just left the two really hard ones. Yeah, I don't want to do those. No, I'm just kidding. I think we've done the hardest ones. Questions on that? You ready for one more section of work? Take a look. So find an equation of variation where y varies directly as x and y is 80 when x is 10. Okay. An equation of variation. What does that mean? An equation of variation sounds fancy. It means y equals k times x. You'll recognize that this is called direct variation. Direct variation. We're going to also have inverse variation in a couple minutes.
But you haven't taught us f of x, a function of x.
Yeah, I'm trying to think where that is. That's somewhere, isn't it? Maybe it's...
Maybe I'll
I can't remember where that is. Yeah. I don't know. Yeah, it made me wonder. I'm not sure. Maybe it's only in the next class. I thought... Yeah, I can't remember. It might just be in the next one.
My 201, she tried to teach us f of x, and it was a really hard... She didn't explain it very well. It was really hard to grasp.
All right, so y equals kx. So this is what you want to put on your 3x5 card. Whenever it says direct variation, you want to write y equals kx. In a little bit, we're going to have inverse variation, and then the x is going to jump down below, but I'll write that out when we get there. But just heads up, there's direct and there's inverse. So we'll do the inverse. I'm not going to write it all out right now. We'll get to inverse problems in a little bit. But just giving you a heads up, it just means the x will invert. X will go down below the k instead of being directly next to the k. So direct variation, the x is directly next to the k. In a little while, 20 minutes or so, inverse, the x will go below the k. All right, so direct variation. So what does that mean? Well, they're telling you what they want you to do is find the k, then rewrite y equals kx and plug in the k. And plug in k. So that's what they're saying. They're saying take that y equals kx, find k, then rewrite it and plug in the k. What do we mean? Well, see what they're saying, y is 80 when x is 10. So put in the 10, put in the 80. So 80 is k times 10. So far, so good. And they want me to solve for the k.
K times 10 divided by 10 equals 80 divided by 10.
Yeah, so how do I solve for k? I divide both sides by 10, don't I? Yeah, exactly. So divide by 10, divide by 10. That's what I mean by find k. So then k will be what, 8? So we found k is 8. Then what do? Then rewrite, so now rewrite y equals kx, but plug in the k you found. What is k? 8. So that's all they want. Y equals 8x. We'll talk about what that means. In a few minutes, we'll get to real life word problems. But for now, let me just give you the steps. We'll get to the real life stuff in a couple of minutes. So, what do we learn? When you will see on the exam we take Monday, there'll be two or three, at least two. One problem will say direct variation. The other one will say inverse variation. So when you see those words, that's how you'll distinguish these word problems from the ones we did a couple days ago, or was it last time? Last time, which was what? Working together and travel, right? How you're going to tell these apart is it'll say direct variation. It'll go blah, 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 varies directly. As soon as you see it, you go, oh yeah, y equals kx. Just write y equals kx, plug in, find k. We got it. Okay. Well, here, let me move on. I'll come by and check with you. All right, let's see this next one. So find an equation of variation. Y varies directly. There's that buzzword you want to see, right? Y varies directly. So you know what do we write as soon as we see y varies directly? Y equals kx, right? All right, so you know what to do. Decimals, you should calculate it. Oh, no. So remember, you got to find k, and then rewrite, plug in the k.
Trust you.
Oh yeah, you just kind of go, you just go back to the y. All right, so we're going to write y equals kx twice on these, right? That helped thinking about it that way. We're going to really write it twice. And so the first time, we're going to put in, what is it? Y is 0.7, 0.7, or just 0.7, same thing. X is 0.3. Good like that? How do you,
Divide by 0.3.
0.3. Do they want, yeah, I didn't notice, we can't use our calculator. Because if you use your calculator, you'll get 2.33333, won't you?
Yeah.
And we can't do that. We can't go with 2.333. Why not? Because they said fractions. See, the blue line wants fractions. Sorry, I didn't notice that. So instead, you can just move the decimal one place on both these, and it's just 7/3. You can just leave that k as 7/3. Everybody see what I did with the decimals? I moved the decimal on the top one, and as long as you move the top and the bottom decimal the same amount,
See the way the same.
it's okay. I'm really multiplying by 10. That's what I'm effectively doing, top and bottom, but I'll just move the decimal, same thing. So it's just 7/3. Just leave it 7/3 because they want fractions.
But yeah, the answer's going to be y equals 7/3 x.
Exactly. Yeah. That makes sense because we write the y equals kx twice. The first time we plug in and get k. The second time we just put in the k. We don't put in the y and the x. Does that make sense? I know it seems weird, like why are we putting in the x and the y the first time, and the second time? Well, we'll get to it. We'll get to real life ones, and there'll be a reason for it. There'll be a rhyme and a reason. But for now, that's the process. You write y equals kx twice. The first time you plug in the x and y and solve for k. And then you write it again. The second time you just put in the k. You don't put in the y. Yeah.
Why are you putting the decimal?
Oh, we can't have decimals and fractions mixed. Yeah, so we got to mix here, so we got to move the decimals, make it a normal fraction without a decimal mixed in. Is that good? So everybody see what I did? I just moved the decimal to the right, made it 7/3. So we don't want decimals within fractions. Okay.
So our answer will always have that x on there. It wouldn't just be the other answer, right? If you
Right.
Plug it in.
It's going to have the x on there. Yep. Well, for now. They're going to change the game in a minute, but yes for now. So y equals kx, you write it twice, right? You write it twice. And the first time you plug in x and y, find k. The second time, you just put in k. Everybody see that difference? Y equals y, whenever they say direct, and the key word that you'll look for on Monday's test, you'll see it, varies directly. So when you see varies directly, you go, oh yeah, that's the y equals kx, put that on your 3x5 card. That's the y equals kx, write it twice. First time, just plug in x and y and find k. Second time, just put in the k. And you're done. So whoops, didn't put in the y. So what's the y? Kind of scribbled it up here. 525, yeah.
K times 70.
Equals k times 70. Yeah, 70 for x, 525 for y. We good so far?
15
And then, yeah, we got to solve for k. Divide by 70. Oh, yeah, no, that's not nice, is it? You're going to have to reduce that thing. What, divide by 5?
15 halves.
5 and top bottom? 105 over 14. What does it do then? Did I do that right? 105 over 14. Does that reduce further? Do you got to divide by 7 then?
That's the decimal, the Casio natural.
Remember, we can't have decimal because they said fraction.
15 halves.
Oh, divide by 7 now, huh? Now divide by 7, and k will be 15 over 2. Yeah, that's a tricky one. Casio natural display will do it kind of automatically. So 15 over 2. You okay with all that reducing? That was kind of a tricky one. I didn't think about the 7 there at the end. Right? So I took y equals k. Whenever they say direct, we put y equals kx twice. Plug in x and y, solve. Then I had to reduce that quite a bit, 15 halves. Now, on part 2, you have y equals kx again, but this time you just put in the k. What's the k? 15 halves, and you're done. That's all, nothing more. For now, we're going to move it on in a minute.
Question.
Yeah.
Okay, you got your first y equals kx.
Uh-huh.
Broke down first plug in and x. What
X.
is that?
Oh, that's an amber sign. That's an and. X and y.
Okay.
So first plug in x and y, find k. Second time, just put in the k. Again, there's not a lot of good reason for this yet, but that's coming. Makes sense so far? So we always write y whenever, and how do we recognize this on Monday's test? Varies directly. That's how you know it's not like a travel problem or a working together problem, those ones we did last time. It's varies directly, and you go, oh yeah, varies directly. That's y equals kx twice. All right.
Sir, let me ask you a question. If we know all the known values, why aren't we solving the equation?
If we know we don't know all the known values. We know we're establishing a relationship. It'll make more sense to see a real life word problem. Let me hold off till we get to the real life. James.
Where'd you get the divide by 5?
Oh, yeah, I just thought, I got to reduce this thing. 525 over 70. You know, just reducing a fraction.
Okay.
I just said, yeah, 5 will go into both those. Yeah, and then I got this, and then I didn't know what you mentioned. It reduced, and I went, yeah. Just fraction reduction there, yeah. We're thinking all these fancy KXY things. I want to make sure you're comfortable before they do. All right, so try that one. What's the key word you'll see on Monday's test?
Variation.
Varies directly. Varies directly. All right, as soon as you see varies, because in a minute they're going to say varies inversely. And then the x will go under the k.
21 over 4.
So write y equals kx, y equals kx. When they say varies directly, write it twice. The first time, plug in x and y, solve for k. The second time, only plug in k. This one come out a little nicer maybe. So what's y? 420. And what is x? 80. Good to there? How do we solve for k? Good like that, yeah. So 420 over 80, yeah, you can cancel the zeros, so it's 42 over 8, and that'll reduce even further, won't it?
Yes.
21.
So divide top and bottom by 2, or top and bottom by 2. That'll go 21 over 6. Oh, that goes even further.
21 over 4.
Oh, 4. What am I doing? Sorry, I'm having technical issues here.
16.
And that's as far as it goes, huh? 21 over 4. Good. So we got our k. That's part 1. Part 1's all about plug in x and y, solve for k. And now we just pop that in for part 2 and we're done. Good like that? Questions? All right, I think you're ready to go to. All right, now I want to give you a shortcut way to do this. Paycheck varies directly as hours. When they say that, and they give you 1, 2, 3 numbers. So let me just write this out. When given 3 numbers and the words varies directly, do the A over B equals C over D ratio. Now, Math Excel is going to show a little bit different way, but I found this is easier for students over the years. How do you know when to do this? I know this might seem confusing because I just told you, when it says varies directly, do the y equals kx. Well, I'm saying when they give you 3 numbers and varies directly. 3 numbers. On the last 2, 3 problems, 4 problems, whatever it was, they only gave me 2 numbers. 2 numbers.
Well, if you pick the equation apart, the person's paycheck would be the total, which would be equivalent to y, correct? And the y is.
Yeah, you can do it that way. You can do it the other way, which is what Math Excel will show. All right, so I'm going to do this ratio, and it's going to be, I'm going to put hours over money. You could do it the other way around. It doesn't matter. Remember, it's just like these ratio ones we did last time. So I'm going to go 16 hours is 97.12. 16 hours is 97.12. 43 hours, now where's that one going to go? According to my setup, 43 hours, should it go top or bottom? Yeah, I put hours on the top. You could totally do them both upside down, it's fine, as long as you're consistent. And so what's going to be the bottom? That's my x. Just like we did last time. Remember the ratio ones? Remember that? So basically, if she got 97.12 for 16 hours, how much is she going to get for 43 hours? So how do I solve that for x? Diagonal, diagonal, right? 16x equals 43 times 97.12. Remember how we do those with the diagonal, diagonal?
Yeah.
Cross multiply? Somebody get that? What's that? What's 43 times 97.12? 4176.16.
Yep.
And then last step to solve for x.
Divide by 16.
Divide.
61.01.
What is it? 261.04?
01.
01? Like that?
Yeah.
261.01?
Is that the answer?
That's her paycheck. Does that make sense? Did everybody see the difference between this problem and those other ones? There's three numbers. That's the difference. There's three numbers. Three numbers. So then we just handle like a ratio problem.
This is the inverse?
No, this is still directly.
Oh, okay.
Yeah, this is still directly. They'll actually say inverse in a minute.
It should be.
What's that?
And this is only when it's like the ratio, given three numbers and it varies, right?
Exactly. Because it said directly, and they gave me three numbers. That's right. Three numbers and directly, just make it a ratio, like we did last time. Good. Okay. Try that one. The cost to fill a sandbox varies directly. So there's the key word. Varies directly. How many numbers are they giving you? Yeah, do you see them? 7? 770 and 10. So it varies directly, three numbers, you know what to do. Two equal fractions, right? The ratio thing. No, that's just our answer over there. Yeah, that's it. Good. Yeah, we're not, the reason we're not doing what like a lot of stuff is because those.
It was obvious.
That's what I'm saying.
You already know that. I didn't know. So I did it. It's memorized.
All right, so three numbers, and directly, what do we do? Now, this is easier. Everybody seeing the difference? Those first problems only gave me two numbers. That actually made it harder. It's actually easier when they give you more numbers. When they give you three numbers, you'll recognize it just like it's like what we did last time. So I'm just going to go 7 inches is $70, and 10 inches is I don't know how many bucks. It's going to be 100, isn't it? Yeah. So diagonal, diagonal. 7x is 10 times 70. Which that's 7x is 700. Last step, you're going to divide by the 7. So x is $100.
I love those problems you can set it proportionally like that. It makes it easy.
They're quick and easy, aren't they? Two equal fractions. Yeah. We good? All right. Along with all the... Yeah, that's right. They always advertise all these crazy weight loss programs. There's one. Let's go to Mars. Or moon. I mean, moon. We weigh a lot less. What do you weigh? I think it's 1/6 or something, isn't it?
Yeah.
All right. So I don't care. They're saying varies directly. How many numbers are they giving me?
3.
3. 1, 2, 3. You know what to do.
160 equals 27%.
So just do moon to earth or earth to moon, whichever way you want, but be consistent. Whatever you set out, follow your own pattern, and what do we do? They're giving me three numbers.
First bit, 160.
They're saying directly and three numbers. So I'm gonna probably do Earth to Moon. Earth on the top, Moon on the bottom. But you could do it the other way. Just follow whatever you set up. And then use a calculator. Bunch of messy decimals. They want you to round to the nearest tenth. The blue line says, always watch the blue line. How do I know if the 240.59 goes top or bottom?
The bottom, because that's the ratio, equivalent to the unknown.
Well, I put Earth on the top
Oh.
and Moon on the bottom. At least in my setup I did, right? The 160.41 is Earth.
The way it says in the statement.
And what does it say? How much would a 240.59 pound person weigh on the moon? They're asking me the moon weight. So this is an Earth number, isn't it? So it goes on the top, huh? Does that make sense? If they're asking me for moon, the 240.59 must be Earth.
It's gonna be 50 because you're in.
Everybody see that? See how I knew that?
So I said. No. I already knew it.
Diagonal, diagonal.
So we got the round right.
Yeah, round to the one decimal place, tenths. So what's that, 27.27 times 240.59? The right side? It's like 500, 400, 500, 500 something? Anybody got it? Or 5,000? Is it 5,000? Oh, it's 5,000 something, isn't it?
6,000.
6,000, 6,000, okay, 6,000.
560.
What is it?
6,560.
65, 60 point
88. 88.
88? 88, 93?
Chemistry class, we're going over significant digits and stuff.
Yes. And then last step to solve for M? Divide by 160.41. Boom, boom. What is it? 40.9?
Yeah, because you're gonna round up because
You rounded, right? So,
Oh, is it 0.8 something?
no, it's 0.9.
Oh, 0.9. Good. 40.9. There we go. 240-pound person will only weigh 40 pounds on Mars, on the moon. I keep saying Mars. All right, let's keep going. All right, try that one. How many numbers we got?
We got 1, 2, 3.
Got 80, 240, 10. So you know what to do. You don't even need to read all the words. Blah, 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 blah. Who cares? Just follow the units. You got feet. You got pounds per square inch. You got feet. You know, I'm just going to go feet over pounds per square inch. You know, you don't even need to read all the words, huh? And it must, and it says directly right there as well. So 80 over 240 is 10 over x. Diagonal, diagonal. 80x is 10 times 240. 80x, 2400. Last step, divide by 80. X is 30. Good? Well, just two equal fractions, just like last time. When they say what? What are the key words you're looking for?
varies directly.
Direct and three numbers, huh? Direct and three numbers. There's definitely going to be one like that on the test. I have no idea.
Now, what would be awesome is if you had to convert them to
not doing chemistry here. All right, so there's the varies directly word. I only need to read the rest of the words. Blah, 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 blah. Varies directly. 1, 2, 3 numbers. But if you're interested, this is like a real life use of it, basically, right? For planning a meal, right? For a golf tournament. Number of servings varies directly with weight. Now we start to see what the real life thing is. Basically, varies directly is something that happens all the time in life. Right? If you read a recipe that says, what does it say? For, if you have 11 kilograms of the meat, that'll serve 36 dinners. So what if you go to the store and you buy 17 kilograms? How many servings is that going to be? See how they vary directly? They go together, right? More kilograms, more servings.
2.2 kilograms
Less is less.
1 pound.
Okay, I'll take your word for it. So same old thing, right? I'm just going to do it quick because I want to get onto the new kind. Kilograms over servings. So 11, 36, 17x. Same old thing, right? But see how this is useful? How like a chef would, for example, use this to find out how kilograms and servings go. They go directly together. Does that make sense? Diagonal, 11x, 17 times 36. Somebody got that number? What's 17 times 36? 612, thank you. Last step, divide by the 11. X is 6.
55.
Oh, what is it, 55?
Yeah.
Just straight?
No, 55.63 repeating.
0.62. They say round to the nearest whole number. So how do you round that to a whole number? 56, right? So in other words, it's about 56 servings. It'll make about 56 dinners. And so there we go. We expected it to be more than 36, huh? Because it's more meat. So 55 seems reasonable. 56, I mean. All right. We're going to get to the real deal. Very, very real here. So, all right, so they're going to say, okay, a production line produces 12 CDs every 4 hours. How many CD players in 39 hours? All right. This is the first question they're asking me. Is it direct or I actually answered it for you already? It is direct variation. Let me talk about, well, you could solve the final answer easy, right? How would we solve that one? It's the same thing. We got 3 numbers, right? So it's CDs over hours, right? So 12 over 4 is, where would the 39 go?
Bottom.
I put hours in the bottom, so it'd be like that, huh? Does that make sense? So let's just solve it first. It's just like all the rest. 12 times 39, 4 times x. Somebody got that? What's 12 times? 390 something.
468.
4, thank you. 468. Last step. Divide by 4. What's that? Final answer? 13? What is it?
117.
Oh, 117. I'm way off. 117 exactly?
Yeah.
Okay. So the answer is 117 CD players. But I want you to see that that's direct variation, not inverse. Now they're going to start questioning us what's direct and what's inverse. Let me give you a real life example. If you study more at college, probably your GPA goes higher. Right? We would survey everybody in the school and ask them how many hours of homework they do per week and what their GPA is. Those would go together. Right, direct relationship. So more hours per week of homework, probably higher GPA on
Oh,
Oh,
average.
so if you're looking at it
Lower hours of homework, lower GPA. So it doesn't mean just up. It means together up or together down.
If you're
Right?
looking at it on a graph.
Hold on, I'll get there. More hours of homework, higher GPA. Less homework, lower GPA. Okay, now, let me give you an example of something that would be inverse. How about more hours surfing the internet? Maybe.
Right.
More hours
Yeah.
per week surfing the internet? We have surveyed everybody in campus. Maybe we would find lower GPA. And less hours surfing the internet, maybe we would find higher. See the teeter-totter? Those have an opposite. Maybe hours of watching TV or something. Lower GPA. More hours TV and internet, less GPA. Less hours TV and internet, higher GPA. Maybe it's work, right? More hours of working at your job, lower GPA. You don't have any time to study. Or less hours of work, higher GPA, right? Those would tend to have a teeter-totter, which means inverse. More work hours drives your GPA down, huh?
Less work hours drives your GPA up. See how those have an opposite? Not a direct, they teeters on it, right? As opposed to homework hours and GPA, which are direct, up and down together. Make sense then on the inverse direct? So inverse means opposite effect. So if you say, I'm working more and more hours, well then probably you might experience a lower and lower GPA because you don't have to say. So they're opposite. I'm cutting back on my hours. My GPA is going up. Maybe you have more time to say. Make sense? Opposite relationship? Alright, so what is this relationship? Hours of employees and number of CDs they're cranking out. More, right? Isn't this hours of players? Oh yeah, no, producer, yeah. A production line, yeah, employees, production line. So production line, it's people working. If they spend more hours working, they're going to crank out more players. Less hours working, less players. Those go directly, don't they? It's not a teeter-totter. That's why it's direct. And it's 117. Okay, so... Okay, 6 hours for 5 cooks. How long for 9 cooks?
Okay, this is that one kind of problem that we did.
Okay, let's first answer the question. Is it direct or is it inverse? Think carefully though. This isn't easy to get the hang of it first.
No, it's inverse.
Think carefully. Just ask yourself, how many hours do the people need to work on the dinner? And how many cooks are working? If you're saying, we've got more cooks on the job now, is that going to make the total time? If more people work on the job, it takes less time. Make sense? Right? More people working on the job, any kind of job, more employees, less total time to get the job done. Right? These are inversely related. Do you see that? More people on the job, less total time to complete the job. Right? Less people on the job, job's going to take longer to complete. That's why it takes so many Caltrans workers out there. They want to get those jobs done fast. I'm kidding. Seems like they're always out there forever. Anyway, right? So does that make sense? More workers, less total time. Less workers, more total. Inverse. Teeter-totter relationship, right? So, inverse variation is the first answer. Right? Everybody good with that? Yeah. Hours down when cooks are up. Now, I haven't shown you, we've only got 10 minutes left here. I might have to go about 5 minutes over. I got to show you how do we solve. Now, earlier I told you for direct with 3 numbers, you do A over B is C over D, right? Equal fractions. Remember that? Yeah. But now I need to tell you for inverse, because this is an inverse one, with 3 numbers. Right? They give me 3 numbers, right? 6 hours, 5 cooks, and then 9 cooks. So how do you do inverse with 3 numbers? Well, instead of fractions, you know what it is? It's side-by-side multiplying. Like that. It's almost the opposite of what you would think, huh? You would think that inverse would be fractions, and direct would be like directly side-by-side, but it's opposite. Actually, is how it is. And I don't have enough time to show you more of the theory of why and stuff, but we just got to get through these. So you use this equation for direct with 3 numbers. You use this equation for inverse for 3 numbers. Okay, so what am I talking about? Let's take a look. So 6 hours, 5 cooks, 6 times 5. Instead of 6 over 5, 6 times 5. And what's the other one? 9 times x instead of 9 over x. Does that make sense? It's actually a little bit easier. Everybody seeing what I'm doing there? Instead of making 2 equal fractions, which I would for direct, I'm making 2 equal multiplications because it says inverse. Which is kind of counterintuitive, huh? We would normally think inverse is fractions. Anyway, so what does that become? 6 times 5 is 30. How do you solve for x there? Divide by the 9. Do they want what kind of answer do they want? I don't know if they want a fraction or decimal or whatever. 30 over 9, you could reduce it, divide by 3, top and bottom.
3.3?
Yeah, they probably just want a decimal, huh? It's just 3.333. Whatever they want. There's 2 versions. I don't have time to fiddle around with what they want. Either one there. On the test, you can get all decimals. Just turn everything into decimals with your calculator.
Good there? So it take them about a little over 3 hours for more cooks to do the job. That makes sense, huh? Took them 6 hours for 5 cooks, but if you crank it up to 9 cooks, you get the job done quicker. A little over 3 hours to get the meal prepared because more people are working.
There's almost twice as many, so it'd be like half.
Yeah, like half the time, kind of. Yeah, good. All right, so everybody see that difference? We have the two. There'll be one of each of these, and there might even be a third one. But for sure, there'll be one direct and one inverse, and then maybe one other thing I can't remember. It might just be 2. Anyway, one direct, one inverse on Monday's test. For direct, 2 equal fractions. For inverse, 2 equal multiplications. Right? All right, let's. What aren't you talking about back on this one? Oh, yeah, it's off the screen. Is it? Yeah, it's kind of shifting. Yeah, I'll tell you. Oh, it's 18. Yeah, it's an important number too. Let me put it over here. It's 18 miles per gallon. That's what should be over there. Yeah. All right. So this one tells, see the word right here? Inversely. So this time they're not leaving us to guess. They're just saying inverse relationship. Inverse. So when they tell you inversely, and they give me 3 numbers, which they are giving me 3 numbers, aren't they? Got the 18, the 30, and the 15. Yeah, 3 numbers. So what am I going to do? A times B is C times D. If it was direct, I'd make 2 fractions. But if it's inverse, I make 2 multiplications. That makes sense? Can you finish it from there? Very practical question here, right? 15 gallons of gas.
A car that gets 18 miles per
You're going to need 15 gallons to make a trip, but a car that gets better gas mileage will need less, huh? It's an inverse relationship. Better gas mileage, less gas needed, right? It's an inverse relationship. So anyway, so we just go 18 times 15 is, what's that other number, 30? 30, yeah. 30 times x. Is that what it is? So what's that? What's 18 times 15?
270.
Oh, that is the 270. 30x. How do we solve for x? By 30. X is 9. That makes sense? That's how much gas? 9 gallons of gas. Less gas when you get better gas mileage. All right, a couple minutes over here to finish this whale for y'all. All right, let's do this one, number 20. Yeah, this is the number, so it's not off the screen. So 90, 24.9, and 209. And it says inversely, doesn't it? So inversely, 3 numbers.
Will it ever be less than 3 numbers?
Yeah, it will. I need to go back and show you one of those. There was like 5 of them, but I skipped them. Because honestly, I'm not going to put one of those 2 number ones on the test. I'm just going to put the 3 number ones. So there's just going to be 3 number ones on the test. All right, so you know it's A times B is C times D. What is it? 90 times 24.49 is 209 times X. What's that left side?
2204.1.
What is it?
2204.
2204.1.
How do you know it's multiplied together?
Is that good? And then how do we solve for X? Divided by the 209. And they want us to round 2 hundredth means 2 places, right? What do we got?
10.5.
I need one more decimal. 5.
2.54.
5459.
So that, yes, remember how to round? So they're saying hundredth. Remember the hundredth, remember how the places go? Hundredths is the second. So remember when you circle the place you want to round, you look 1 to the right. If it's 5 or more, you go up. So 10.55. Does that make sense? Remember the names of the places? The first place after the decimal is called the tenths place. Then the hundredths. Okay, hold on now. Okay, last thing I need to show you, inversely and only 2 numbers. This is not going to be on the test, but it is in your homework. Back to number 11. I went backwards because I skipped them because they're not as important. I wanted to do a good job on the last stuff, which is on the test. But they're like, I think it's number 11 through 15, might be 14. They all are inversely with 2 numbers. Problems 11 through 15. So problems 11 through 15 are all inversely with 2 numbers. See, they're only giving me 2 numbers, not 3, like that. So in that case, you got to go back to the y equals k stuff. But instead of k times x, that's for directly, you got to write y equals k over x for inversely. Yeah, let me put inversely over here. For inversely, you got to write y equals k over x. All right, so then y is 2. Remember how it works, right? You got to write it twice. Remember how we did that before? You got to write it twice. Plug in y is 2, x is 3. Remember that? You got to find k. Remember the first, this section is all about finding k, and then this section is plug in k. Remember how that works? So how do you solve this for k?
K over 3 times 3 is equal to 2 times 3. So
Yeah.
x equals k.
Everybody good there? You got to multiply both sides by 3 because that'll cancel it and get k alone. So k is 6. See what happened there? So whenever you have a denominator, you got to multiply both sides, right? See how we're always doing the opposite operation, right? If you have something divided, you multiply it. Multiply, you divide. Yeah. And so then bring that up here and put it in. Y equals 6 over x. We're done. That's all they want. So there we go. So we made it. Those 2 sections are due, which is what, 6, 8, 6, 9? Complex fractions and the inverse direct stuff are due on Monday, and exam number 4 is Monday. Look at practice exam number 4. It's under announcements, right? Yeah. Practice exam number 4. And we'll review the first hour like normal. It's open. Click A. A for Apple. It is open. And have a good weekend. I will see you Monday. Roberto's available for help.
I was thinking right in, trying to pay attention at the same time. How do I know which ones to plug in? Because in this, I plug it in, I plugged in the wrong ones and I got the same answer.
Oh, did you?
I got 36 because I did MPG times 30.
Oh, yeah. Remember how?
I didn't write the question.
Yeah.
I write the whole question down.
Good enough.
To know, but
Remember how there we go. You know how it's feet and pounds? See how we have a mix? We don't do feet with feet. And we don't do pounds with pounds. No, we feet with pounds when they're up and down. Well, it's the same thing side by side. So I don't want to do MPG with MPG. I want to do MPG with pounds. MPG with pounds. Yeah. And then MPG again. See side by side, but the same thing is up and down. We do the mix. Mix. Yeah, so just like that, you always mix. So the answer is you never do the same MPG with MPG. You mix just like we always do. Well, there were some other words in there I can show you.
okay, maybe